Okay, good afternoon, Prof. So I'm Jamie and I'm representing Team Pending. For our topic today, we'll be talking about multi-threading in JMS queues. So this is our content outline, and I'll be talking about multi-threading. First of all, let us cover the concept of what is multi-threading. So basically, it is the process of executing multiple threads simultaneously, and this is actually to maximize the CPU time. So a multi-threaded program can contain two or more parts, which are called threads, that can run concurrently. So how does JMS enable multi-threading? So basically, JMS applications can be written to be multi-threaded, and multiple sessions have their own JMS producer objects being driven by separate threads. And it is important to note that even though the server is multi-threaded, the listener or consumer can be single-threaded. So now I'll pass on to Claire to talk about async communication and concurrency.
Hi, so I'm Claire, and I'll be talking about the relationship between async communication in JMS queues and the concurrency that we have learned in AA. So just to recap on what the definition of concurrency is the ability to run several programs or several parts of a program in parallel. If a time-consuming task can be performed asynchronously or in parallel, this can improve the throughput and the interactivity of the program, which is basically the main point of AA. So how does this go hand in hand with JMS queues? Okay, so to have async communication in JMS queues, the first step is to register a message listener. So this is an example code. You can just declare it as listener my listener is equals to new listener. Consumer.set message listener bracket my listener inside. So this helps to register a message listener called my listener. We then can edit the onMessage method to implement the logic behind the JMS queues. So this is where concurrency comes in. Upon receiving a message, the listener is called in a separate thread. The original thread also continues to listen to the queue. So this means that while the original thread is listening to the queue, upon every single message that is received, a separate thread will be created and created and created. So there will be many concurrent threads running at the same time. So now I'll be passing on my time to Yi Xiang, who will be talking about counting the number of concurrent threads.
Okay. So I'm Yi Xiang. I'll be covering the counting of concurrent threads. So in JMS, there are actually these threading restrictions where JMS mandates that a session not be operated by more than one thread at a time. So what it simply means is that for every session, you need to use one thread and one thread only. So if you refuse to follow this, you'll get a JMS illegal state exception. So how to find out the number of concurrent threads is actually by counting the number of concurrent sessions that you are currently having. So you can actually use the method JMS connection runtime mbins.session current count. So this way you'll find the current count of the sessions. So moving on, if you're actually using JMS consumer and you want to have your consumers concurrently message consumption, so for each consumer, a session will be created, and like mentioned before, every session uses one thread. So it's also as good as saying one thread per consumer. So if you're using JMS thread pool, you can actually set a fixed number of threads. So in this case, the number of concurrent threads will be fixed by you. So for example, you want to say 10, so there will be the maximum number is 10. So however, at the current point, you might not know how many threads is actually running. So it could be up to 10. Okay, next I'll pass you on to Gerald.
Hi, I'm Gerald. So I'll be presenting on the pros and cons of JMS over Java thread. So the advantage of JMS over Java thread is that there are mainly 4 points that I'll be covering. First of all, it offers guaranteed delivery. One message must be consumed by one consumer. And what JMS assures is that for every message sent to the queue, it will always be received by one consumer. Even if the system goes down, it will still be retained in the queue. Second of all, it provides load balancing. It can handle a large amount of requests by distributing it to other servers which are subscribed to the queue as well. So in cases where one server that subscribed to the queue is down, it gets redirected to the other server. So this helps in load balancing in a case where the application needs to handle a large amount of requests. Third, fault tolerant. So when part of your architecture fails, it doesn't need to take the entire system down. In that, if a process that is processing messages from the queues fail, messages can still be added to the queue to be processed when the system recovers. Fourth point, scalability. Processors to handle message requests and app is decoupled in the sense that no codes and configurations need to be changed, and scaling is as simple as adding more power to the Java queue message server. So next I'll be discussing the disadvantage of JMS over Java threads. So first of all, it has higher complexity. So not only are you concerned with the application server configuration, you need to take note of the JMS configuration as well. Essentially, you are adding one more layer of one more layer to your application. So this means that you need more system checks and balances. But you also, with JMS, you also introduce asynchronous data distribution and acknowledgement. So this needs to be taken note of. Third point, different vendors of JMS implement standards differently, in a sense that such as one vendor such as ActiveMQ or another might interpret the standard differently and implement it differently. So for different projects, depending on what vendor you use, you have to do your code differently for your programmers. However, this is not the case for Java threads, as all the API remain largely standardized in the same JDK version which you use. So with that, we'll end the presentation. Thank you.